All right, so let's look at our machine learning series. This is part 4. I want to look at the difference between categorical and continuous data and the supervised learning in machine learning. So yesterday I demonstrated how we can do this quite easily, and so if you could remember, I can just pull up my my slides, and then of course I can show us how so yesterday we were able to, when we looked at this particular graph or this particular chart here, we have a supervised learning on top there, on supervised learning, and we realized that each of them has some kind of an algorithm that is supposed to be used. But to choose a specific algorithm under either supervised or unsupervised learning, it depends on the data. So if the data is continuous, and then the data has, if it is continuous and it falls under the category of supervised learning, you should know that it's supposed to be a regression, a decision tree, or random forest. If it is categorical, then that's classification. Today, I want us to go to RStudio and look at how to be able to differentiate these two. Okay. Right, so we're on RStudio now, and of course, all right, so it appears my RStudio, the variables are the font size is really, so let me look at appearance. I'm just trying to change the font size. Let me take it to 150 and see, maybe this may look a little bit better. Okay, so yeah, it is, what is it? It is better. Okay, so let me pull this up a little bit. I'm just trying to see if I can close this up. Well, I'm still finding it difficult to close that pop-up menu. Maybe I should just close entirely and open it once again. This may help. Okay. I've already done some. Okay, so this is where we are. I just wanted to increase the font size. After that, I couldn't scroll up to where I could just close up. All right, so but this font size is a little bit more visible now, and so it's easy for us to explain whatever that we are coming to do. So here, I just want to demonstrate in RStudio here how are we able to separate the two study groups. We have supervised learning and we have unsupervised learning. Under supervised learning, we either choose the algorithm based on the nature of the data. If the data is continuous, then, or if the data is categorical. So first of all, we are going to look at a categorical data and how to be able to apply machine learning, especially supervised learning, on that. So I'm just assuming that the population, we just selected the population of Ghana, a sample, and then we are looking at their preference in terms of the mobile network that they want. So let's say, and so I decided to simulate the data set. And so we have the gender, whether they are male, female, the age group, and then we also look at their occupation, and we look at their salary and the preferred telecommunication network. So I just simulated this. I decided to randomly simulate all of that, and I decided to create a data frame, and that data frame is named mobile usage. Okay, like the preferred telecommunication. So you can see I have MTN here, and I have Vodafone here. I wanted to just have a categorical data. So after that, I build up this particular a data frame, and we can have a view of the data frame. Look at how it is. And so we have the gender, age, occupation, salary, and then preferred telecommunication network. Okay, so you can see either Vodafone, MTN. So now let's see, if we have a data like this and we want to apply machine learning, what are we going to do? Possibly one thing comes to mind. You check and see whether the data you have a dependent variable. Of course, here our dependent variable is the preferred telecommunication network. So it's either MTN or Vodafone. So we want to find out whether is MTN people prefer or is Vodafone people prefer. And we want to, so that is going to be our dependent variable. And then our independent variable will depend on their age or their gender, occupation, or salary. So the rest will be independent, and this one is the dependent. And once we have a dependent variable, we can, the kind of learning algorithm we can, the kind of machine learning we should apply here is supervised learning. And because it is also a categorical dependent variable, then we can apply the algorithm classification. All right, so we get in the difference here. So now I have my data frame which is ready. And so what is the next thing to do is I'm simply supposed to load this particular tool, because that tool allows us to be able to split the data into training sets and then a test set. Remember, we are building a model, and we always train a model before we test the model. And so we are going to train the model for now. And so to train the model, we have to first of all split the data into any ratio at all that we want. So we use this particular function split dot a sample dot split, and then we go into a data frame, and we are splitting the data based on a particular variable. So we are using the dependent variable as our key reference in terms of the splitting. So we are here, and so the function is going to go into the data frame, go into the preferred telecommunication variable column, and then perform the rest of the splitting. The split ratio is 0.65, and that is going to form our training set. So when we run that, we have splitted the data, but unfortunately we could not find the function sample.split. I'm sure that I'm supposed to have loaded this. I'm supposed to load the CA tools. So now if I run it, then that, you see that. And so after I've done that, I need to do some subsetting. The subsetting here is simply saying that this subset function is going to the data frame, and is going to go into the training set, is going to go into the split, and it will realize that we have splitted some data B, and then if that split is true, we should pack that data into something we call training set. And so what is it? I'm just going to do that, and then again we are going to also, those that are not in that particular ratio, that's the rest of the other 35%, we also take that to the test set. And so now we can actually run we can see that, so we have our two, this is our training set, and then we have our test set. So now we are ready. We've split the data into two. The next thing to do is to simply load this library called part4, and that's what is going to help us to be able to create the model. And so we are going to create the model. So we are using the preferred telecommunication network has been trained. Now when we move from there, the next thing is to now do a prediction. So we are going to predict, and what I'm going to predict, we've already trained the model, which is here. So the next thing is for us to make sure that we predict using the test set. So we now run the predict function using the model that we have, and then run it using the test set on the model. because we've already trained the model. Now put the test set there and see what is going to come out. And so that's where we have here results, and then we put it there. So now when we finished, the last thing for us to do is to simply just build our confusion matrix, and we can use a table function. Table is a function in R, and of course when we do that, we are going to bring the test sets as against the preferred telecommunication and then the results. So when we go into the test set, we are just picking only this particular column, the dependent variable, and then we are matching it against the results that we have predicted already, and it will print our confusion matrix for us. And so when we do that, as you can see, our confusion matrix is now here, the bottom there. So we can see MTN Vodafone here. So we'll see what is going to happen. So we are simply saying that the first prediction is for we have predicted that this is the total number of people who are using MTN, the total number of people who are using Vodafone. But in actual sense, this is the real is 5 people who are truly using MTN. The model has predicted 3 people who may while they are not using MTN, but it predicted that it is using MTN. When we come here, the same 3 people who have been predicted to be using Vodafone, but in natural sense is this particular 3 which are actually using Vodafone. So that's why we have true, negative, and then true, positive, and then a false positive and false negative, and that's the confusion matrix. To be able to compute for the whether the model is good or not, we add the leading diagonal, that's 5, and that will give us 8, and then we divide it by the total sum of everything. So I'm just going to say I have 5 plus 3, that will going to give me 8. So I'm going to have my 8 divided by 9 or divided by 14. If you add everything there, that will be just going to give you 14. And so the prediction accuracy is 57%. So we can say that the model accuracy is 57%. And then that is how it is. That's how in machine learning, that's how the model performs. It's not a bad model, but it's not also a very good model. We were expecting an accuracy of around 80%, but when you see it like this, it's a model that you can implement it with a lot of caution. So you cannot say that many Ghanaians preferred MTN as against Vodafone. Is the accuracy. The accuracy is that when you pick Ghanaians, you want to find out the preferred network, there's a 57% chance that most of them will choose MTN. But that is just a simulated data. That's what this model is all about. And that's how we are able to analyze, we are able to use machine learning to do some kind of prediction when the data is categorical in supervised learning. Now let's look at when the data is continuous. And here I'm going to load the ggplot. So I'm just running the ggplot. So I just load it, ggplot2, and ggplot2 has a lot of data sets which are found within it. And so, for instance, I don't know if I should run data, and then I'll just put ggplot2. Okay, maybe I should put it in double quotes, and then I have ggplot2. If I run it, doesn't. Yeah. Oh well. I shouldn't have put the codes there, but in any case, let's go ahead. Inside the ggplot2, there is a data set called diamonds. You know, our ladies like a lot of diamond rings, especially for engagement and whatsoever. Now, these diamond rings are sold based on some qualities and then some other things. So the price, so let's just have a glimpse of what this diamond is all about. So I'm going to run that and then fold this up a little bit and then look at how it looks like. So this is the diamonds that we have. So we have the carat here, the cats, that's the quality. The carat is the weight, and then the color, the clarity, how transparent or how clear it is, and all the depth, the table there, and then the price. So in that case, we have a dependent variable here which is called price. So it means the price of each diamond depends on the rest of the independent variables which we have them here. So we want to use machine learning to be able to find out to build a model that can accurately predict the prices and see what will be whether if the quality is this way or that way, what will be the price. And that is all that machine learning is all about. So we are saying that if the quality should go down, or if the color, we change the color, which particular color is much more what I preferred, of course, in terms of clarity, what are we going to do? So we're going to look at how these independent variables have explained the dependent variable, which is here, which is the price. So, and because the dependent variable is continuous, it's not categorical, so we cannot use classification under supervised learning. The algorithm we can use here is regression, and then we need to know that. So, because I am saying this based on this, because we are going to use the dependent, once we have a dependent variable, it means we are dealing with supervised learning. And because it is a dependent variable, because it is a continuous, the dependent variable is continuous here, then we can only use what? Regression. And here we're going to use linear regression. Just pay attention to that. Let's get back to RStudio. And so what I'm going to do again, I have this tool which is already there. I just loaded it once more, and then let me pull this down a little bit. So here we do the same thing. We just split. I'm just going to split. I just split it to 65% of the data. I'm going to call that the diamond split, and then after that I'm now going to subset it into the training and then the also the test sets. And then when I do the two, you can see that the training and the test sets are now ready. So that's why I call it the diamond train and the diamond test. So the next thing is to build our linear regression model, and to do that we use the function lm, that's the linear regression. So we bring the dependent variable which is called price, and here we have our price here. So let me see if I am okay. So our price, and then we bring this tilde. The whole of this is this is how we read it. The dependent variable explained by the rest of the independent variables. And when you put point means the rest. So we don't want to waste our time listing all of them. Programming is all about lazy people. Like, you don't want to waste time writing plenty things. So that's why I just put point there and comma. And what data are we going to use to train the linear regression model? We're going to use the training data. So the diamond train data that we splitted, which is here, that's what we're going to use. And we pack the whole thing to this particular resource, which we call regression model. That's so I just do that and that run properly. Then the model we have now built, we now use that particular model to predict. And so what are we now going to predict? We are now going to use the test data set and then put it on the model that we have built and see what will be the results. And that's what we always do. It's quite a simple process. But unlike in the categorical data, where at this point all that we need is to just come out with our confusion matrix, here it's not like that. Here we have the actual prices that we have, and then we also have the predicted prices. Now let's see whether the actual prices will differ a lot will differ, or it will be the same as the predicted prices. If it is the same, it means that the model is good. It means that we can say that anytime the quality of the diamond is like this, and the color is this, and the whatever is this is supposed to be the price. And that's all that we're trying to do here. So what are we going to do? We have to do a C bind. We are going to do column bind, and we go to the actual and then select only the price. And when we go to the actual, see here we are creating a variable called actual, and that actual, what is the variable we are giving it to? What's the data object? We are using the diamond and the test, and then we select the column price. You see, because we are using the test now, because we have already used the train to train the model. So we now pack that into actual, and then the predicted, we've already done the predicted, which is in the resource, and then we pack the resource into the predicted, and then we put everything as a column, as a data frame, and then we call it final data final, which is also there. And so when we finished, we convert the final into a data frame, and that's what we just do here. As a data frame, we convert it, and then we still pack it into what we call final. And of course, we can just catch a glimpse of how it's going to look like. So if I fold it up, you can see we now have our actual prices, which is here, as against our predicted prices. So the actual price of the first one was 326 Ghana cedis, but the model predicted that it should be around minus or something. We take the absolute figures, and then this is what we have here. So we can look at the actual price and then the the predicted price. But that's not all. when we do like this, we need to be able to estimate the error. So between the actual and then the predicted, what is the error? If I plotted a graph, you will see a linear regression, and then you see all the points that fall above and below the line are always the errors. So, but in mathematical work, or like what we are doing, we can actually calculate that. And to be able to do that, you subtract the predicted prices from the actual prices, or the predicted value from the actual, and that will give us our error. And then our error is now what is it there, and that's where we have this particular line. I just run that line, and so after that we now combine our final data with the error. And when we do that, that is going to give us. And now let's have a head and look at how it looks like. So now we have our actual data. This is the predicted and this is the error. And so we have the two, so we can now know how the model is performing. But to further estimate, to further understand how this particular error, you can see it comes with some negatives and whatsoever. But so in that case, we need to regularize that. And to be able to do that, we take the root mean square error. And then that's how we can normalize the data, or we can normalize the results. And when we do that, we pack everything to that variable called the root mean square, and this is the syntax, R followed board mass. And then when we do that, we can just have it there. And then when we print our root mean square error, then we see that this is the figure that we have, and this figure is what we are going to use to explain whether the model is good or it is not good. The higher the figure, the better the model. So when you calculate your root mean square, it's going to give you one single variable, and it has to be continuous. So so you can see that it's a continuous variable, and that's the difference between categorical and then continuous variable and the supervised learning in machine learning. So now we have our model, and then we know how to be able to actually do the prediction. Perhaps we could have we can plot this final data and see how it will look like. And then let me go here and see what if I can plot it, and then you see how that's going to look like. And just pull this a little bit and see. So the data set is quite heavy, so it will take time before it will plot it up, and then you see how that's going to look like. But before the plot comes, this is all that we are trying to do. We just wanted to know the difference between I don't know. Yeah, the plot is in now. And so here now we actually have the actual and the predicted and then the error. So we have the actual, the predicted, and the error. So if we want to look at the actual and the predicted, we can see that if we put the predicted at the y-axis and the actual on the on the y-axis and the predicted on the x-axis, we can actually see the trend. Whilst when the actual price are going up, the predicted is also going up. So that's actually a linear kind of thing. When we come here, it's also upward sloping, but sloping at a reduced rate. And of course, we can see some kind of shapes here. But when we come to this place, we are looking at the error and then that of the predicted, and then we can see some kind of a downward slope, and then in that order. So when it comes to interpretation, I will get to that point and I'll do a video on that. But this is just what I wanted us to see. If the data is categorical and then the dependent variable is there, then you are using supervised learning and you are using classification. So you are looking at confusion matrix. If the data has a dependent variable and the dependent variable is continuous, then you are using supervised learning and you are using a regression, or you can also use a decision tree or a random forest. Each of them I'll demonstrate, but that's how you are able to do your machine learning, to be able to predict something. Model is all about predicting the future, or determining the market and whatsoever. I'll be doing logistic regression, and then I will also show you how you can use machine learning to detect fraud and other things. Yeah, so we'll be doing it step by step. But for today, that's the difference between categorical and continuous data and the supervised learning, and then how to be able to analyze them and reports. Thank you. I hope you've learned something. If you find it interesting, please, why don't you share the video, and then I'll allow others to also benefit. Sorry for at the beginning, it was a little bit humpty-pumpty, but it's okay at the end. Thank you, and if you like it, please make sure you already subscribe to my YouTube channel, and of course please share the video and then invite your friends to also support in that regard. Thank you. Bye bye.